right, so notes today on sine and cosine graphs. So we'll talk a little bit here first to start about some observations that you should have gotten from your sine and cosine graphs when we graphed them last week, Friday. So if you wanted to have out your sine and cosine graphs that you made on Friday, you can definitely have those out as kind of a reference of them. Okay? So I'll trace over here the first lap wave. So sine we started with. So our first lap wave is that one there. And our first lap cosine wave is there. Okay? So what are some of the observations that we can come up with? Well, we've got about, I think, 7 or 8 different ones down here. What can you tell me about the domain of sine and cosine? Can we ever not put something into sine and cosine? Take it one step back. We talked about this on Friday. What do we put into the sine and cosine function? What? No? We put in what? We put in angles. Okay? So are there any angles that we can't put in to sine or cosine? No, we can put them all in, right? Okay? So then what's the domain of their function? No. Domain is inputs. If there's not anything that we can't put in, what's the domain? All real numbers. Okay? So both of them, so domain is inputs, all real numbers, everything works. Okay? Range is outputs. No matter what we put in, so we're putting in angles, no matter what angle we put in, what do we get out? Just one? So it's always within that range? Okay, never outside of that range? That was an obviosity. Yep. So the range will always be -1 to +1, and those are inclusive because we can be at -1. We can be at positive. Okay? Which means then, for our function, we have a high point or a maximum value. We have a low point or a minimum value, and we have a middle value. Okay? So what would the high point be? 1, low point, -1, middle, 0. Yep. Okay. Which means then we have something called an amplitude. Okay. An amplitude is the distance middle to high or middle to low. Okay? So from that middle number, the middle of your function, to the highest point is the amplitude, or from that middle of the function to the lowest point. That is also the amplitude. It's a distance, so it's always positive. So what is the distance from 0 to 1 or 0 to negative 1? 1. So the amplitude here is 1. Okay. We have a starting value. Okay, so these functions, both first lap started at 0, and then we were back in the same spot, going the same direction at 2 pi. Okay. Meaning on the sine curve, we were back at 0, going up, increasing at 2 pi. We were back at positive 1, and then switching to decreasing at 2 pi. And we were back at the exact same location, position on the curve as we were at the start. That creates something called the period. The period is the horizontal distance to get back to the same spot. You find the period by taking end minus the start. So in this particular case, our period was 2 pi. Okay. The other observation that I can tell you is that the sine curve starts in the middle, then it goes to the high point, back to the middle, then to the low point, and ends in the middle. Middle, high, middle, low, middle. Okay. Cosine starts on the high point, goes to the middle, then low, back to the middle, and then ends at the high point. Okay? That pattern will always be true unless we have some kind of transformation that changes it. But that's the basic pattern. Okay? What we are going to get into now is we are going to get into the transformations of sine and cosine. Okay? These two formulas, or I shouldn't say formulas, these two equations, here's our cosine equation, here is our sine equation. Those two equations are going to be very beneficial for you. And we're going to have all kinds of different things to go along with those things. So our A value, which we'll end up learning all about, our A value is going to be our vertical stretch. That's going to yank the sine and cosine curve vertically. Our B value is going to be the horizontal stretch. We're either going to stretch it out lengthwise, or you'll horizontally expand it out, or we can contract it in. Our C value is going to affect the starting location. So actually, that's going to be, I should say there, that's going to be a horizontal shift. And our D value is going to be our vertical shift. And we'll break that down over the course of the next few days. Okay? So today we're going to focus in on A and D because those are the easier ones to figure out. And then we'll move to C's, and then we'll move to B's. Okay? All right? Now, when we go to graph these, we are only going to be graphing first lap waves. So you're only going to have to graph one of the waves. Okay? Right? So the first one, let's talk about, is going to be our A value. Our A value is going to represent the amplitude. So that's the vertical distance, again, from the middle to the high, or the middle to the low. So of all of those things that we just observed about sine and cosine, A has direct control over the high value, the low value, and the range. Because on a test or a quiz or a formative or whatever we want to give you as an assessment, a homework sheet that we're going to give you later on today, okay, we're going to ask you different questions based off of those 9 different things that we can choose from that we just figured out. Domain, range, high, low, middle, start, end, period. I think I'm missing one. Amplitude. Okay. We're going to ask you all of those questions based off of those. Okay? All right, let's get into it. So this is your first graph. Now, all you really need is, and actually later on what's going to happen is we're not even going to have these axes on your paper. We're going to add the axes in last. Okay? Right? So for right now, though, because we don't have very many horizontal or vertical shifts, you could draw it in, and you could actually draw it in even more like that. Because we're not going to go negative right now. Okay? So our graph is y equals 2 sine of x. So that tells me that my A value is 2. Okay? Everything else is going to stay the same. So my domain is going to be all real numbers. That hasn't changed. My range, that's going to change because remember, it's controlled by A. My high, my low, all controlled by A. My middle is still going to be 0. My start is still going to be 0. My end is still going to be 2 pi, and my period is going to be 2 pi. Because none of those change, because A only affects range, high, low, and amplitude. Okay? So if 2 is my amplitude, then 2 is my amplitude. Which means the distance from my middle to my top would be 2. So that means my high is going to be at positive 2. 2 is also my distance from my middle to my low. So that means that's going to be negative 2. Which means the range of my function is going to be from negative 2 to positive 2. This is a sine curve, correct? So a sine curve starts in the middle, goes to the upper, back to the middle, to the lower, and ends in the middle. So you can start by drawing in your sine curve. This next part is the crucial part. Okay? Now we have to label our axes numerically. I will tell you, if this were a graphing question on a summative, it would be worth 3 points. 1 point for what we have right now. Okay? Just the picture of the function is 1 point. The labels on the vertical axes are worth 1 point. The labels on the horizontal axes are worth 1 point. So if you just give me the graph, you're only getting 1/3 of the points. Okay? That's how important these are. So it says that we went all the way up to 2. We went in the middle at 0, and we went all the way down to negative 2. That's worth 1 point right there. Okay? We started horizontally at 0. We ended horizontally at 2 pi. Halfway would be what? Pi would be halfway. Half of the first half would be pi over 2. Half of the second half would be 3 pi over 2. We asked for all 5 of those labels because those are going to be either a middle, a low, or a high on all 3 of those spots, or excuse me, on all 5 of those spots. Okay? On a cosine, it would be high, middle, low, middle, high. Okay? And that, ladies and gentlemen, is a complete graph of y equals 2 sine of x. Okay? You now try y equals negative 3 sine of x. So, a value is negative 3. Okay? Does that affect the domain? No, so the domain is still all real numbers. Does it affect the middle? No, so the middle is still 0, which means that an amplitude of -3 would mean my high point would be at +3, my low point would be at -3, which means then my range is from -3 to +3. All because my amplitude is 3. It looks like -3 in the problem, but remember amplitude is a distance, so it's absolute value. Okay? Does the amplitude affect my start? No. Doesn't affect my end, which means my period is 2 pi. Now, here's the trick part of the trick question. What is the cosine value at 0 degrees, 0 radians? Is what? So, but really, cosine just in general at 0, 0 degrees, 0 radians. It's cosine value is +1. Then I got to take that times -3. That gets me the -3. So this one actually starts down low, goes up high, and ends down low. Okay? Which means we're up to 3, middle is 0, and we're all the way down to -3. Which means horizontally, we're at 0, end at 2 pi, halfway would be pi, halfway would be pi over 2, other halfway would be 3 pi over 2. Okay? So it should look like that. So just so you are aware, as a side note, if you have a positive a value in your function, the sine curve looks like that. The cosine curve looks like that. If you have a negative a value, your sine curve spins around, and your cosine curve also flips over. So positive A's, it's normal, middle, up, middle, down, middle, up, middle, down, middle, up. And if you have a negative A, that reverses. Try that one. One's fun. High point is 1/2, middle is 0, low point is -1/2, starts at 0, goes to pi over 2, goes to pi, 3 pi over 2, ends at 2 pi. We scared of fractions? Shouldn't be. As long as they're in the A value, it just changes what our amplitude is, but it can still be that. Huh? So we did A. Now, let's talk about D. D, what D does is it changes our middle. So now our middle is going to be adjusted a little bit. Okay? And this would work even if this were cosine also. Okay? Same thing happens on both of those. Okay? A lot of times you'll see us write cosine over sine there in that one because it doesn't matter which one we're dealing with. All of these things affect them the same. Okay? So our D adjusts the middle, which now then that has control over your high, your low, your middle, and your range. Okay? It doesn't have control over the amplitude, because that's A's job, okay? But it's got control over everything else. Okay? On top of, it actually supersedes A's control over all of that other stuff. Okay? So, let's do this one. Now, depending upon how you write it, these two things right here mean exactly the same thing. So we could write it like this. That's typically how we write it. We write it with D at the end. But NTC, because you are all in a dual credit class, NTC likes to write it like that, where they put the D in front. Okay? They mean exactly the same thing. Okay? All right? Those two mean exactly the same thing. All right? So, with that being said, yeah, write a little smaller. Okay? What is my domain? What's the domain of this function? It's the same answer, and it will always be the same answer throughout the entire rest of your life. What's the domain of this function? All real numbers. What's the domain of a sine function? All real numbers. That part, that's the one constant. That will never change. Okay? It's always going to be all real numbers. Okay? What is the amplitude of this function? No. What is it? It's 1. Remember, it's the number in front of the trig function. So my amplitude shows up there, or my amplitude shows up there. So the amplitude is 1. What is the middle of this function? 10. The middle is this value after a set of parentheses or out in front. So my middle is 10. So now if my middle value is 10, what's my high value? 11. What's my low value? 9. Okay? So this switches to 11, which this switches to 9. So now my range is from 9 to 11. Start and end and period, we'll get to those switches, I think, maybe tomorrow. If not, for sure on Tuesday. So here is where, whoa, hey now, what is going on? Something just got installed in my computer. Oh, still. Anyway, okay. So what I was saying, here is where, okay, it's a cosine curve. I am going to draw my cosine curve just out in space somewhere. Go a little higher over here. OCD kicks in every once in a while. Okay? So I'm going to just draw that out in space. What is being installed? Hey, caramba. Okay? And then I'm going to adjust my axes. Okay? So after I draw, I almost said after I install, but after I draw the function, then I can put in my axes. Okay? Because now this is way down here at 9, my middle is 10, and my top, my high, is 11. So I wouldn't want to have this for it because that's not true. Okay? So 0 is way down there. Along my horizontal then, this would be 0. This would be 2 pi. Halfway would be pi. Halfway would be pi over 2. And halfway would be 3 pi over 2. So it helps to draw your axes in after you draw your function in. Okay? Try that one now. So much so that I'm actually going to even move my axes. I'm going to move them way over here, way up there, and then that way they're out the way. So if my middle is at -2 and my amplitude is 4, that means my high value is +2 and my low value is -6, which would give me a range from there to there. +4 on my amplitude tells me it's a normal sine curve. Vertically, I started at 0. So that one would go there. My middle is at -2. So this right here, I'll label it, is -2. My high is at +2. So therefore, my 0, my horizontal, would have to go in the middle of that. And my low would be -6. 0, pi over 2 is at the high, pi is at the middle, 3 pi over 2 is at the low, and 2 pi. I will tell you, right here, right now, on problems like this, where it doesn't match up, like, it doesn't, it's kind of a little shift right there, this right there is not the middle. So that's not where pi goes. I've seen it 1,000 times that this middle label of pi here, you're going to want to go there because that's where it crosses the axis. Doesn't always happen. Doesn't always happen. Questions, comments, concerns, clarifications? Good times. I will hand out now a worksheet that you can start working on. This will be due the day of the test, which I think is the Thursday before break.